Good morning. Here's the answers to the surd questions that I set last week. A little bit more straightforward, hopefully, than the previous stuff we'd done. I suppose these two are perhaps the only fiddly ones where root 20 is root 4 times root 5, so it's 2 root 5. If you've got two lots of it, it's 4 root 5. Of course, your calculator will do these for you, and it's probably worth experimenting with typing in those sorts of questions, because it's a little bit fiddly. You have to sort of use your cursor to sort of shift out of the square root. So that second one, root 80, I then have to go right to come out of the square root, minus 2 root 20, right to come out of that, plus 3 root 45 equals, gives you the answer. Why bother learning to do it? Well, I think it is important that we remember these techniques, because exam boards are very good at throwing in questions with missing values, the sort of algebra where the calculator doesn't help you. Anyway, let's move on. So still with surds, just a very quick reminder of something which is in the induction booklet, and I've already done a little video on it, but I think while we're sort of working through Unit 1, I want to make sure we do everything. So when you're multiplying out surds, hopefully you're going to grid it out like this, and where you've got a different square root in each bracket, you don't end up with a nice easy answer at all. So here I've got root 3 times root 2, which is root 6. That's the reverse of the rule that we use when we simplify surds. So the square root of 3 times the square root of 2 is the square root of 6. Root 2 times minus 2, we just write that as minus 2 root 2. Just as if that was x. X times minus 2 would be minus 2x. Same thing. 4 times root 3, 4 root 3, and minus 2 times 4, minus 8. Now, those of you whom I teach know at this point I always look forward to peanutting, collecting terms. I can't. I've got 4 different terms, so my answer is, it doesn't really matter what order you write it in, it's not particularly satisfactory, but that's it. Can't get any simpler than that. So here's a one where the square root is the same in both cases. So 3 plus root 5 and 7 plus root 5. So this one ends a little bit happier. So we've got 21. I've got 7 root 5. I've got 3 root 5. And here, this is the key result, isn't it? The square root of 5 multiplied by the square root of 5. The square root of 5 squared is 5. And I go from no peanutting to double peanutting, because I've got 21 and 5, so that's 26. And I've got 10 root 5. Sorry, for those of you who've got no idea what I'm talking about, it looks a little bit like one of those peanuts in shells, so that's why I call it peanutting. Okay, so sorry, I haven't made it very clear there, have I? But if you just have a go at those two, this is the only practice we're going to do of these, so just pause the video and have a go at those. Okay, so one on the left was sort of an unsatisfactory one because there was no simplifying at the end. Just make sure you got this right. So root 2 times root 5 is root 10, and it's a mixture, minus times plus, so it's minus root 10. A bit happier over here. We've got 7 lots of root 3. This is the key result here, isn't it? Root 3 times root 3 is 3. 7 times minus 2 is minus 14, and minus 2 times root 3 is minus 2 root 3. And then I can combine my answers. Well done if you got those correct. Okay, so the new thing I wanted to talk about this morning was the fact that a lot of the things we've been dealing with over these last few sessions, both things written as indices to the power of and surds, can be written in two ways, surd form and index form. So for example, this is a surd, square root of 2, root 2, but we know that we can write it as 2 to the power of a half. So these two things are the same. This is it written in surd form, this is it written in index form. So what about something like 2 root 2? Well, if you think about that as a multiplication sum, it's 2 multiplied by the square root of 2. So if I write that in index form, 2 on its own is 2 to the power of 1, and that is 2 to the power of a half. And you remember what we do when we are multiplying powers of the same base? We add the index numbers. So we do 1 plus a half, so our answer is 2 to the power of 1 and a half, which I'm always going to write as 3 over 2. So I'll go through that one more time. So this is 2 times the square root of 2. If I write that in index form, 2 on its own is 2 to the power of 1. The square root of 2 is 2 to the power of a half. If you multiply powers of the same thing, you add the index numbers, so you get that. And so I can do that for this one. 4 is 2 squared, so that becomes 2 squared times 2 to the power of a half. I add the indices, so I get 2 to the power of 2 and a half, which looks really odd, doesn't it? But that's what it is. Obviously, I can't simplify this, can I? This only works if I've got, if the number there and number there can be written as the same power. So this is 3 times root 2, but I can't then combine that in this way. So that one can't be simplified. So that's best left in surd form. But these 3 can be simplified in the same way as these. So again, pause the video and just see if you can have a go at writing those 3 in index form. So there are the answers to those 3, and hopefully you can see where I've got all that from. Now I think going back the other way is more complicated. So don't forget, on the right here we've got index form, on the left we've got surd form. So if you're given something like this and asked to write it in surd form, you've got to think, okay, can I think of this as coming from an expression like this? And so hopefully you'll be able to say, right, so that's 1 and a half. So that's 5 to the power of 1 times 5 to the power of a half. And hopefully, therefore, you could see, right, that's got to be 5 root 5. Go back the other way now. So taking that and breaking it down into that is the key. And then once it's written like that, realising that in surd form it looks like that. And we can do this with algebra as well. I mean, this is x to the power of 2 and a half. So it's x to the power of 2 times x to the power of a half. So that is x squared root x. So just see if you can have a go at those 2. And then I've thrown in a couple of negative powers as well. Just see if you can pause the video again and work out what is happening there. Write those in write those in surd form. Okay, so this I split up into 7 to the power of 1 times 7 to the power of a half, so it's 7 root 7. This is 2 and a half, so it's 7 to the power of 2 times, it's 3 to the power of 2 times 3 to the power of a half. 3 to the power of 2 is 9, so it's 9 root 3. These 2, well, you know the way I tend to work, I tend to do it without the minus sign first. So I know that 3 to the half is root 3. So 3 to the power of minus a half in surd form is just 1 over. Remember, minus power means 1 over that. So this is what 3 to the power of a half is. So 3 to the power of minus a half is just 1 over that. And 3 to the power of 3 over 2, I'm going to ignore the minus sign for the moment. So that is 3 to the power of 1 times 3 to the power of a half. So that's 3 root 3. And I'm going to write that as 1 over 3 root 3. Now some of you might be saying, hang on a minute, we've been told that square roots on the bottom are bad news, and you are quite right to remember that. And that's what we're going to come to on Friday when I post the next video. But for now, I'm just going to leave it like that. So forgive me for leaving it like that. Okay, finally then, Let's just look at some slightly harder examples of this. So in these questions, we're given something in surd form, and we want to write it in index form, but it's a little bit more complicated because everyone we've done so far, this number here has been a power of this number here, and it's different in all three of these. So the first one, I'm being told to write it as 4 to the power of n. So I'm going to start by writing everything as powers of 4. So I've got here 4, which is 4 to the power of 1, times the square root of 64, and that is 4 to the power of 3. 64 is 4 times 4 times 4. Okay, the square root means to the power of a half, so that means, and this is bringing in the stuff that we've done recently, because do you remember the third indices rule says that I can simplify this by multiplying the 3 and the half together. So I've got the 4 to the power of 1 that's still there, and that is 4 to the power of 3 times a half is 3 halves, 3 over 2, 1 and a half. And so I've got powers of 4, so I add the index numbers. 1 plus 1 and a half is 2 and a half, which I'm going to write as 5 halves. So that is how you do that one, and that's quite fiddly, isn't it? So we wrote it all in powers of 4, we simplified the surd into index form, and simplified the final one. You know what I'm going to say now? Pause and have a go. Okay, here are the answers. Now some of you would have got this answer straight away. So well done if you spotted straight away that the square root of 9 is 3. So you've got here 3 times 3, which is 9. But if we want to write that as a power of 3, then it's 3 squared. Brilliant. I still went through the same method up here in case you didn't spot that. So this is 3 to the power of 1, and 9 is 3 squared, so it's the square root of 3 squared. So that's 3 to the power of 1 times 3 squared to the half. Multiply the powers, a half times 2 is 1. So you end up with 3 squared. But again, you know, common sense, you could have spotted that straight away. This one, 9 is 3 squared. I know I need to work in powers of 3. They give the game away. Okay, so that's nice of them. So 9 is 3 squared, 27 is 3 cubed, so it's the square root of 3 cubed, which is also, looks like that, which when you multiply gives you that. So here I've got 3 to the power of 2 and 3 to the power of 1 and a half. So add the indices, you get 3 and a half, which I'm going to write as 7 over 2. Okay, so I'm just going to give you 2 to have a go at, and I'd really like to post your, sorry, not post, email me your answers to this. This one is hopefully relatively straightforward, and that's a bit like the ones we've just done. So no attachment, I'm just going to leave those on the video in the hope that you will be able to have a go at them. I'm slowly phoning round to catch up with people I haven't heard from, but if you are on that list and haven't had a phone call, why not send me an email with your answers to this, and that reassures me that you're taking part. I do hope you are all well, and I look forward to seeing you all at some point in the near future, hopefully. Take care.